to another fruitful discussion. Today onwards, we turn to data and see what it can do. Well, what is the powerful ingredient included in the research? Research topic, then research design, or methodology, or data, the way we are presenting, so on. You may say all the above I mentioned. If I ask what is the impact of data on your research, we take much time to collect data, then analyze data. Then our next task is the visual representation of information. Until data does not speak for itself, so you have to speak for it. That is why we arranged this round. An expert panelist here. Let me introduce today's resource panel. Dr. Tiloka Silva is a senior lecturer at the Department of Decision Sciences, Faculty of Business, University of Moratuwa. Her research falls into the nexus of macro development with a focus of population economics as well as applied microeconomics, focusing on education economics. Her publications include work on demographic transitions and population aging in developing countries and higher education outcomes in Sri Lanka. She is particularly interested in using innovative sources of data for economic-related applications. Our next resource person, Dr. Sandun Dassanayake. He is a senior lecturer at the Department of Decision Sciences, Faculty of Business, University of Moratuwa. Dr. Dassanayake conducts research specializing in spatial analysis and decision sciences with expertise in GIS, remote sensing, and machine learning. Dr. Dassanayake collaborates on interdisciplinary research in sustainable urban planning, geohazard predictions, and optimized geoenvironmental design. Some of his influential work includes papers on developing hazard predictions for wildlife damaged earth dams, urban heat islands, and acid mine drainage remediation. Dr. Dassanayake's research groups are committed to using advanced computational methods and nature-based solutions for adapting to climate change. Their research further focuses on climate change impact on urban climate using machine learning and statistical modeling to promote sustainable practices in urban planning and risk management. So, dear panelists, research lab is open to you.
Thank you, Nayani. Let me first share my screen. Good afternoon. I hope I'm audible. Thank you, Nayani, for introducing us, and thank you to the FTS for inviting us to do this talk today. So what we are going to talk about is something which is kind of gaining traction in the scientific community of how we can make our research more meaningful or impactful using visuals so that we can kind of promote understanding and engagement related to the work that we do. So before we jump into the discussion, as it were, I would like you all to visit this website, www.menti.com. Preferably join on your phone so that we can have a little bit of interaction with those of you who are connected today. Since you are not here physically, we thought we would try to get you on board through this tool. Once you visit the website, you have to enter the code 3621431. Let me just drop it into the chat as well. 3621. So while you are getting set up on Menti, I want to direct you to a video which both Sandun and I were kind of unanimous on agreeing that we couldn't talk about visualization without showing you at least a snippet of this. It's from a scientist called Hans Rosling, who is extremely passionate about data and data visualization, and his demonstrations are almost magical in how visually pleasing they are. So let's take a few minutes to watch this video and then we will get back to the discussion.
Visualization is right at the heart of my own work too. I teach global health. And I know having the data is not enough. I have to show it in ways people both enjoy and understand. Now, I'm going to try something I've never done before. Animating the data in real space, with a bit of technical assistance from the crew.
So, here we go. First, an axis for health, life expectancy, from 25 years to 75 years. And down here, an axis for wealth, income per person, $400, $4,000, and $40,000. So down here is poor and sick, and up here is rich and healthy. Now, I'm going to show you the world 200 years ago, in 1810. Here come all the countries. Europe brown, Asia red, Middle East green, Africa south of Sahara blue, and the Americas yellow. And the size of the country bubbles show the size of the population. And in 1810, it was pretty crowded down there, wasn't it? All countries were sick and poor. Life expectancy were below 40 in all countries. And only UK and the Netherlands were slightly better off, but not much. And now, why start the world? The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. What a catastrophe! And now I speed up through the 1920s and the 1930s. And in spite of the Great Depression, Western countries forge on towards greater wealth and health. Japan and some others try to follow, but most countries stay down here. Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. United States was in the front, Japan was catching up. Brazil was way behind, Iran was getting a little richer from oil, but still had short lives. And the Asian giants, China, India, Pakistan, Bangladesh, and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier and healthier and healthier. And in the 1970s, then countries in Asia and Latin America started to catch up with the Western countries. They became the emerging economies. Some in Africa follows. Some Africans were stuck in civil war and others hit by HIV. And now we can see the world today in the most up-to-date statistics. Most people today live in the middle, but there are huge differences at the same time between the best of countries and the worst of countries. And there are also huge inequalities within countries. These bubbles show country averages, but I can split them. Take China, I can split it into provinces. There goes Shanghai. It has the same wealth and health as Italy today. And there is the poor inland province Guizhou. It is like Pakistan. And if I split it further, the rural parts are like Ghana in Africa.
And yet, despite the enormous disparities today, we have seen 200 years of remarkable progress. That huge historical gap between the West and the rest is now closing. We have become an entirely new converging world. And I see a clear trend into the future. With aid, trade, green technology and peace, it's fully possible that everyone can make it to the healthy, wealthy corner.
Well, what you just seen in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers. Pretty neat, huh?
Okay, I hope you enjoyed that. Let's now take a minute to get on to Menti. So I hope you all were able to log into the website. So if you go on to menti.com, and enter the code. You will be prompted to, I think, add a username. And then what I would like you to do is, if you have a piece of paper, first think about 3 words that you would use to describe the video that you just watched, and then type it in to the prompts that you will see on your screen on the Menti website. Hope those of you who are joining online are hoping to participate too. Four responses. I think there are around maybe 35 of you online. So let's wait a few more minutes. Okay, so I think I mentioned write down 3 words. Some of you have gone a bit over the count. That's fine. Okay, so let's see. So we have quite a few responses already. This is just listing out the responses that we've got from the audience. So we have visualizing the complex data, visualizing data attractively, population growth, age, and so on. Let me now, and bear with me for a minute, I do have a point. If we can stay on Menti, and I'm going to go into the next question. So ideally, I was hoping you would just write down 3 words. If you can just respond with the same 3 words again, but now where you separate the 3 words into the 3 boxes which are appearing on your screen. So you are welcome to come up with another 3 words if you were using a phrase earlier. Something that would describe the video that you just watched. Six responses. Let's wait until we hit 10. That's 17. And then it's counting. Okay, so what's the point I'm trying to make? So essentially what I asked you to do is to give me the same information in 2 different ways. First, I just asked you to write it down in a single text box. And the next time I asked you to give me the 3 words again, but now in a structured format where each word is shown separately. And rather than showing you the words in a kind of list of comments, I am now visualizing the information as well. And this particular kind of visualization is called a word cloud, where the size of each word represents the frequency with which it's been used by the members who are responding. So basically words which are kind of showing up as bigger are the words which more people have responded with. So at a glance, rather than looking at a picture like this, which is not actually a picture, it's more of a table of text, this particular image kind of gives a snapshot of what more people were thinking when they saw this particular video. And this kind of highlights the whole idea of how you can use visualizations to convey a message effectively, though there are, of course, several caveats. So certain types of data need a little bit more cleaning than other types before they're suitable for a visualization. For example, it's possible that if I had kind of combined or cleaned up this data together, I would include visualization over here, data visualization over here, visualization with a Z rather than an S, all of those together. So if I had cleaned up the data a little bit more, I could come up with an even better graph. But the idea is essentially how you choose to show the data that you have can make a big difference in how your audience sees your results. But underlying that is the kind of pre-processing data cleaning part, which is integral to anything, not just for visualization, but any of your analysis as well. So if we were to get back to PowerPoint. Okay, so when we work with data, and all of you as researchers are used to working with data, we start in the kind of first cell over here. So data is not arranged, it doesn't have any kind of pattern that we can see, it's kind of a mess. And then the process that we follow is we would sort it, try to get some order in our data, try to summarize it and get some ideas about what our data looks like in an overview. And then we would go on to presenting the results visually. And ideally, what we would ultimately be able to do is use the data that we have to actually tell a story related to the research question that we are trying to ask. So very often, most of us, myself included, we kind of stop at the point of presenting our results visually. We just pick some kind of a graph that can show particular facts, but we don't try to put everything together to tell a kind of coherent story about the research that we're trying to do. And very often, if we want to convince an audience or readers about what we are doing and why it's useful and why it's impactful, it's very helpful to put it into a narrative so that it is easier for someone to kind of get on board with what you're saying. So let me give you one other example about how visuals can convey messages that numbers alone sometimes can't. So what we have over here are 4 sets of data. This is hypothetical data, right? Data on 2 variables, X and Y. And looking at this tells you nothing, right? If someone were to present their results in a paper like this, it would be rejected outright. It's just, you can't see any patterns. You can't tell anything from just looking at these 4 sets of tables. So maybe one thing which we could try to do is apply some of the statistics that we know, use summary statistics to try and maybe say something about the data that we have. So here we can see the mean and standard deviation for X and Y for each of the 4 data sets that I showed you earlier. R is referring to the correlation coefficient between, again, X and Y in each data set. And what you can see in these 4 sets of summary statistics is that all 4 of these data sets provide exactly the same summary statistics. So by simply using the summary statistics, if we were to only see these and try to say something about the 4 data sets, it would be very tempting to say the 4 data sets are very similar to each other. The correlation coefficient is 0.82 in all 4 of the data sets. However, if you were to take it a step further and visualize the results, that shows you, okay, maybe the data sets are similar in terms of their summary statistics. However, the story is clearly very different from data set to data set to data set. So, for example, the first panel over here is showing a set of data which shows a more or less linear relationship, whereas the next one has a clear non-linear relationship. The third and fourth have big outliers, which are probably driving the correlation coefficient. So without looking at these visualizations and just looking at the summary statistics, it would have been pretty much impossible to pick out any difference between the 4 data sets that you're looking at. So coming back to you guys and the research that you are all doing, as researchers, you are working with complex ideas and concepts. So let me direct you to an example which one of my professors gave me when I was a new postgraduate student, and the example has stayed with me out of its pure visual power, I guess. So this picture over here is a picture of the London Underground map. So you have all of these different tube lines connecting to each other. This is overlaid on an actual map. This is reality. This is showing you how each of these different lines go and how you would move from one point to another. If you wanted to decide how you would go from a station over here to some station over here, looking at this map, it's very difficult to identify which line you should go on, where you should get down and change to another line and so on. However, if you shift to a more abstract representation, a more simplified representation, where you kind of go a little bit away from reality, but simplify what you are trying to say, your point becomes a whole lot clearer. So if you were now to figure out how you would move from, let's say, Old Street over here to Green Park, you can clearly see you go one station up to Moorgate, and then you shift to the purple line. And basically, it's much easier to plot your path if you are looking at a more simplified picture. So my point here is that you are working with complex ideas and concepts. You are an expert in your own field, but not everyone else is. So if you want to be able to convey your messages or communicate your ideas in a way that other people will be able to follow and get on board, you need to figure out a way of communicating your ideas in a not overly simplistic, but at least a reasonably simple or clear way so that others can also follow along with you. So this is the idea of visualization. Visualizations should not make the reader even more confused when they look at it, but ideally help you to convey your message in a more effective way. So let me give you a couple of examples. So I am from a social science background, so my examples are from that area. Sandun will give other examples which are of a more scientific nature. All of these visuals are taken from The Economist magazine, which is a general interest. It's not a scientific journal, but I find the visualizations are based on scientific research, and they're very attractive in the way they're presented. So I would encourage you to go and check their website. They have a column called The Graphic Detail, where each week they publish different visuals based on research papers. So this one, I won't kind of go into the details, but this one is showing you the climate impact of different types of food. So there's this big debate going on about whether you should be a vegetarian or a vegan in the interest of saving the environment or climate change and stuff. So this particular graph is showing you the emissions of each type of food relative to a particular type of food relative to a banana. So relative to a banana, how many emissions does a different beef burger or a slice of salmon or rice emit? And here the first panel is showing you the emissions by weight. So let's say kilograms. The next one is showing you emissions per 1,000 calories that you would consume of that particular food. And the last one is showing you per 100 grams of protein. So what I particularly like about this visual is it relates things in a way that anyone can understand. When you say everything relative to a banana, that automatically changes the way you're thinking. It's something that I can relate to. Everyone knows what a banana is, right? It also separates the veg, non-veg in a kind of clear and contrasting way. Gray is non-veg, yellow is veg. And then the 3 panels are actually really interesting because it helps you to look at this picture in different ways. So the first one is saying how many emissions per kilogram of rice relative to a kilogram of bananas. But someone might say, you are not going to eat a kilogram of rice and you won't eat a kilogram of, let's say, candy floss. You will eat a much smaller amount of certain types of food or more of other types. So in that case, let's scale it, and rather than looking at per gram, let's look at it per 1000 kilocalories. So when you change it to that scale, the kind of grays which are over at the far corner in the first panel kind of merge with the rest of the non-veg, though still you can see a distinction. The non-veg items are emitting more than the vegetarian items. The last part is then saying, okay, fine. The reason why, I'm just saying, the reason why people who are not vegetarian is because they say you can get more protein, or it's easier to get more protein if you were to eat non-veg food. So here we have the same information, the emissions from each food group per 1 gram of protein in that particular food item. And once you scale it per gram of protein, the distinction between the veg and non-veg items kind of closes quite significantly. So things like salmon become even less emitting than a banana, depending on the dimension from which you are looking at it. So I thought this was a very nice visual in the sense that it has so much in a single picture. We could probably write a whole page or 2 pages simply looking at this particular visual alone. Another one, and here I'm not going to go into detail, but here what we have in this particular image is the relationship between GDP per capita or GDP per person and happiness on a 0 to 10 scale. So essentially looking at the relationship between GDP and happiness. Are richer countries happier on average? And the nice thing about this graph is, even though it's a 2-dimensional scatter plot, it also has a time dimension included. You have each symbol over here, you have a bubble and a stem. The start of the stem is the first point, 2005 to 2008. And the bubble is the ending point, 2015 to 18. And the color of the symbol, whether it's red or blue, is showing you whether over time, the two variables, GDP and happiness, have moved in the same direction or not, right? So what this picture is then showing us is, overall, if you look at all of the data points taken together, the relationship between GDP and happiness is positive. Richer countries tend to be happier. However, if you were to also look within a country over time, it doesn't necessarily follow that a country that has got richer has got happier. So the red countries are all countries where GDP per capita and happiness have actually gone in opposite directions. So by looking at both the cross-sectional picture as well as the temporal picture, we are actually seeing a mixed message. You wouldn't be so quick to say the relationship between GDP and happiness is always positive. The last one that I would like to show you or bring to your attention now is basically an exercise where they have tried to look at whether you can predict how often a country is mentioned in the kind of scientific literature based on its GDP. The idea being countries that are richer tend to be studied more, right? So this first graph is just a scatter plot showing the average GDP of the country against how much it is mentioned in the literature. But what I like to kind of bring your attention to is the right-hand side of this visual, where they have visualized the results of a regression analysis. Now, I don't know how many of you use regression analysis in your research, but I do a lot. And I always stick to kind of this tabular representation of my regression results. And it had never crossed my mind to think of, can I show these regression results using a graph, for example? But this particular, the bottom panel over here is plotting those graphs where you have the confidence bands as well. So you can comment on statistical significance, and you can also see relatively which of the predictors considered are stronger in terms of predicting how often a country is mentioned in the research. So for example, GDP is the single biggest factor that would predict how often a country is mentioned in the literature, like we would expect. But there are other factors which also have kind of statistically significant impacts on how often a country is studied. So these are just a few examples. Like I said, visit the Economist website. The graphic detail, I think you can access without a subscription. It has some wonderful examples of ways that you can visualize things kind of outside of the beaten track. Okay, so I think I've been speaking for long enough. So Sandun will also share a couple of his favorite drafts with you now.
Right. Thanks, Tiloka, for setting up the pitch. And it was really nice to see some of the facets of socio-economic aspects of data. So actually, I'm more looking into the aspects of science here, how different visualizations have made history. And I have picked particularly 4 examples that I feel would really give a nice impression. So let me go one by one. Perhaps some of you might be working in thermodynamics in related research. So this particular plaster sculpture is actually created by one of the most prominent physicists of all time, James Clerk Maxwell. And what he has shown here is the thermodynamic surface of water. So you have temperature, pressure, and molecular volume in different axes. And then you have this surface, because back in the day, I think this was made back in 1876. So back in the day, they didn't have these 3D visualizations or computer visualizations and stuff. And this physical depiction of the thermodynamic surface of water gave researchers the chance to look at the different isothermic surfaces or pressure points and see how water's thermodynamic nature would change. And that's a really interesting visualization. One, because it is not just something that's on the paper. It's actually there. You can touch it, so you can physically see how it changes over different domains and different aspects of your parameters. And it has been identified as one of the most prominent visualizations in statistical physics and thermodynamics, because it gives you a good view of how it changes. And then next, I'll move to another one that's related to war and how a particular army has reduced its numbers from entering Moscow. So this is how the Napoleon's army has reduced it in size when they try to enter Moscow. And if you read about this, you'll find a very nice story how they could not account for the weather and the seasonal variations and the slope and all the other whatnots around that area has caused them to deplete in size as an army. So the left-hand side, as you can see, is giving you the size of the army as they started invading or entering Moscow. This the thickness of it, and then they have entered Moscow with very depleted number of men. So then afterwards they had to retreat, and you can see how the retreat has also caused the reduction in their sizes as well. So it's also a very well-known figure in visualizations. So if you can perhaps read about it more, then you get more interest about this as the guy. So let's look at another one. This is related to public health and health in general. So this is COSCOM's plot by Nightingale. Florence Nightingale has been appointed as a nurse in a military British Army hospital, and then they have been recording data, of course, for a long period of time, but they couldn't see any cause or causation or correlation about certain aspects of what they have found, the challenges they have found, because they didn't visualize data in terms of month, and they couldn't visualize the variation or the number of different casualties and other things, because they didn't have the necessary technology or the necessary know-how to visualize such. And this is COSCOM plot, where you have each of these segments, as you can see, belonging to the 12 different months of the year. So January, February, and so on and so forth. So if you actually look at this, it's actually giving you an idea about the annual thing as well as monthly variation of casualties and other important factors. Right. So with that, I move into one of the founding figures of geoinformatics. Actually, now we call it geoinformation systems and all these new words, but this is where it all began. This is the John Snow's dot map. This has a very nice story. So there was a cholera outbreak in London, and people were like dying, and everybody was blaming it for the weather. And then they thought that cholera was spreaded through air. So they thought it as an airborne disease, like coronavirus. But they didn't have any clue of how to stop this. Then this doctor, what he did was he had the addresses of all the people that he could find, and then he put those data on the map. And they found that the density of the people that have been affected were more close to a certain location where you can find this contaminated water. And then they realized that the source of this disease came from water, and if you can purify the water, you can reduce the number of casualties and so on and so on. So this is actually thought as the first geoinformatics related visualization, and you can see how even for today we use these kind of images and visualizations to identify the epidemiology and the spread of diseases. So those 4 examples that I have shared with you give you the magnitude and the scope of things that you can do with visualization. One may be from a physics point of view, one is from war and social point of view, and then there was another one from health, right? So this is the scope of visualization that you can do. And then if you can make impactful visualizations of your data like these, of course your research will be cited and you will have a high impact, because the more you are attractive to your peers, the more you will be cited. Now, moving on, I will share the mic with Tiloka to talk about some aspects.
Thanks, Sandun. So I think the examples that you shared with us, even though they were, all of them are visuals coming from kind of several decades or centuries ago, they're still kind of cutting edge in terms of how they are presenting their ideas. But let's move on to something closer to home. How can you, or why should you think of visualizing your results or your research better? So those of you who have already tried submitting your research work to journal articles or conferences, you may know already that many journals and many scientists are aiming for higher impact. Many institutions are also aiming for higher impact. And so one of the things which several journals are now asking for is a graphical abstract of your work. So if you have 1 or 2 visuals which can very clearly showcase what your research is all about, that makes your research much easier to communicate to a larger audience. And again, nowadays, a lot of people are taking to social media to promote their research. And again, you don't want to have social media posts which are like 1,000 words long. If you have 1 or 2 graphs or a single image, that would make your message a lot clearer than trying to get people to read through a 500-word abstract, for instance, right? So the good news is that there are so many visualization tools which are now available to all of us. There are industrial tools like Power BI or Tableau, which are more suited to kind of industrial level organizational visualizations. But even as scientists, there are now a whole host of visualization tools which are now available, and many of them are freely available as well. And actually, there are things which we, and I mean me, once thought were not visualizable, excuse me, which are now relatively easy to do. And actually, one of these aspects was introduced to me by Sandun, which is, so when you think of your literature review, it's often kind of the hardest part, at least for me and for many young researchers as well, to wade through all of the work that has been done in a particular area, find out who has done what, how does your research fit in with what is available, and so on. And at least when I was a student, this idea of visualizing a literature review was not there, right? And I think even still it's a kind of new and mind-boggling idea to me. So let me now pass the mic back to Sandun, who will talk a little bit more about how you can use visuals to position your research within the wider literature.
Right. Thanks, Tiloka. And I think we all learned from the pain in the past. So I learned this after that. I mean, once I kind of get into these things, I thought, gosh, if I had this knowledge before. So I will talk about some online visual analytics tools that are available. So you can connect your literature, particularly to see where the sources are coming from and then how they are interacting with each other. I'll talk about two online visual analytics tools. One is, I think, would be more appropriate for young researchers who are trying to get into a domain, and the other one would be more suitable for people who have taken the toil for some time. So the first one, which is also an open access one, is called Connected Papers. So in Connected Papers, what you can do is you can go to the search bar and then put the keywords that you want. So in my case, being a reader in this area, so I just put naturally spatial and decision sciences. So when I put this, what you can see is I can get several papers that are related to this area, and you can click on one paper. So I click this origin paper because I thought of it, I just clicked it. And then I get a visualization like this. Now, here's the thing. If you go to this how to read the graph part, you can see each node is an academic paper related to the origin paper. So now, for example, let's say that you have a paper that your supervisor might have given you, or you have found, okay, this is the paper that I'm going to build my entire career on. So if you have found something like that, you can search here and then you get this origin paper. After that, based on that paper, you can see how the other literature have been clustered around it. So papers that are arranged according to their similarity are closer. So for example, let's say that in a domain, now in this case, the spatial sciences might be related to healthcare, or it may be related to transport. So depending on the disaggregation, the level of dichotomy, the way they have been changed, or the focus is different from one to the other, the cluster will be different. So for example, we have apparent three clusters here. Some of the papers are more clustered to the left-hand side of your screen. So that makes that this is the domain, sort of. So if you go to the top part of it, you can see more of the clustering there. And that gives you an idea whether, say, for example, you are a researcher from a particular area, particular domain, then you can find the expertise related to that area by looking at the papers in that cluster. So that's just a helicopter view of the research that you are looking at. And the second thing is node size is the number of citations. Now, I'll come to another point after this, but before that, I'll talk about this number of citations. Now, when we talk about research in the graduate level, we tell that your research needs to be novel, and at the same time, it has to be standing on the shoulders of the giants, which means it should be particularly related to a certain research domain that you are looking at. So the number of papers that you are citing or you are referring as original papers should be really connected to the core of your research. Maybe there should be 15 to 20 papers that are really related to that domain. So this node size or number of citations, there can be inter-domain citations as well as intra-domain citations, where you have multidisciplinary research that divert from one end to the other or different areas. Now, if you look at the citation number, you can identify that the peers have more liking, or this particular research has more interest, has gained more interest in the research domain. So you know that it has been cited, so people are talking about this. But be careful, there are papers that have been cited just because they are wrong. Okay, so you have to be very careful when you are visualizing, but bear in mind that this thing is there. And when it comes to the publishing year, it's a very delicate topic, I would say, because when we talk about novelty, whether this research has a future or is it the robust thing, then the the previous years, whether it's closer to the current year, would give you an impression about whether that particular domain is more sought after or whether it's emerging, right? But at the same time, sometimes past papers that are maybe published in 2010, maybe 2003, maybe back if you're looking at physics paper, maybe 1970, 1904, like Einstein's papers, those are seminal papers for those areas. So sometimes they are not really related in terms of the robustness or the novelty, but still you can get an idea of an overview of how research has been clustered, segregated, as well as connected. So that's one tool that's called connected papers, which I personally recommend for anyone who is a novice researcher and who still trying to understand his area and then try to see whether some papers are connected or not. So that gives a good idea, and it's open access. It's easy to use. The next one is Research Rabbit. You have to create an account here as well. The same goes with the previous one. But here, it's actually, as the name suggests, it's a rabbit hole. If you start going in the spiral motion, it will take you like more and more into the different tangential topics, and it will be a research rabbit. So you have to be very careful where to stop, and you need to know where your scope is. Now, for those researchers who will be using this, my understanding is if you can identify the research groups who are looking at a particular area, and then the institutions who are more focused on a particular topic, then identifying those things can be easily done with this type of visualization. This is called visual analytics. The same principles go here as well, like the size and the color and the one that we discussed previously. So you can nicely visualize your research. Now, these two online tools that I have discussed, they belong to the class called visual analytics, where you can use online tools to read papers without reading papers. Okay. So that gives a very good idea of how research is dispersed in a particular domain and where you should be linking your research and identifying papers. Now, I will move to the next most important thing, visualizing the research using index databases. I think some of the institutions around the world have the access to Scopus and Web of Science. So these are, I'm not going to talk about the essence of index and science index and all these things, but the essence of this talk is that you can visualize how your research can be focused based on the country, territory, the type of the document, the subject area, and if you are, of course, looking for grants, and if you have a very posh kind of a research group, you can think of where your next move is using these index databases, in-house visualization. This is available in Scopus, and of course, it's available in Web of Science, which is, of course, a bit difficult to access from this territory, but still, if you find the chance to have your hands on, then this is the way to do it. You can do it. But of course, I'll give you an open access thing for this, and I'll talk more about it. So it's dimensions. You can do the same kind of a visualization and analysis of your research using Dimensions website as well. The thing is, you just put the keywords, and then once you put the keywords, you get the same kind of thing, but you have to be very careful to choose what you want. Unlike the index, very specific databases where you sort of know that if it is published there, it can be taken as a peer-reviewed paper. The papers available here would be need to be scrutinized a bit more. So you have to be careful, but anyways, it's better than nothing. So one thing is, you can do your research, you can make your query, and then download different types of these database files. One is called bibtex.bib, and the other thing is, there are other things like Excel, CSV. You can find all sorts of types of exporting options if you go and try to export it. I'm telling this because it's very important for my next discussion. So once you are in these index databases, you can do your query and then get the results as a, in this case, .bib file, because I will be using it. Right. Now, Now, this is the most interesting part of the discussion when we go from online index-based visualization to bibliometric visualizations, because this will give you an idea about how to read your papers. Because I know that most of you, when we talk about research students, when we ask them to read, they read all sorts of papers that are not related, or they read a lot of papers that are in one chunk. So at the end of the day, it's like waste of time, in my opinion, because you don't learn how to read and you don't learn how to write at the same time. So bibliometric visualization can be done using the .bib file or the CSV files that I mentioned that you can get from index databases or places like Dimensions. So after you get this file, there are several open source software that can do this, but my personal favorite are the VOS viewer and the package in RStudio called Bibliometrics. So I'm sure some of you might have worked in RStudio, but if you haven't, it's not that difficult. You can go to the website and download it. It is accessible to any type of researcher, so it's easy to follow. So if you install RStudio, then you can install Bibliometrics as a package, and it's very easy. I'm not going to go into details about it, but if you install it, you can use the Bibliometrics package to visualize the data. Now, for this discussion, since VOS Viewer has its own standalone things, you can go to the website, read about it. I will stop that from here, but I'll focus more on bibliometrics because that I use a lot. And some of the visualization that I have done, I can show you here so that you can get an idea what you can do with it. Now, let's move on to the R visualizations. Now, this I will walk you through the process of visualizing literature from here. So all the discussions that I'll be focusing on have been focused towards the .bib file that I have downloaded from my query. So I have done this query being a guy from spatial analysis. I put GIS, transport, and data science to one of the queries that I showed you. So, and I download the .bib file, and then I just included that here. It's not a big thing. If you follow the documents, you can easily follow this. So I'll move my discussion from there. So once you imported the data, you can easily see again a helicopter view of what has happened in this particular area, the keywords. Now, for instance, I specifically didn't remove the time span because if I were doing the research, I would be more focusing on the recent 5 years, maybe 2018 to 2023, but I just kept it for you to see how it is. So the time span is there in the left-hand corner, and then the sources, number of sources means the journal articles or index conferences and so on and so forth. It's there. And the number of documents, I did a very detailed extraction. So there are 225 articles, and then you can see the annual growth rate. Because I did a little variation. I took this data set from Web of Science. There I actually selected the most cited 225 articles because I can give a nice visualization, but I got around 3,000 some articles there. So annual growth rate gives you an idea whether the particular domain is producing. So some areas are there, they are stagnated, or maybe there's a negative growth, which means that's not interested anymore. I'm not saying that you should not be pursuing research in those areas, but I'm saying as a novice researcher who is going into the field to be, to be as an icon among your peers, you should be more focusing on research that are growing so that you get a more better view of what you are doing. And then the number of authors are there, and then single author documents, and then all the other information. And I'll just point at the average citations per document, which gives you an impression, which, as if you remember the Rosalind's video that we showed earlier, here the 30 citations, it's not actually from all the sources that you can find. Maybe the highly cited articles, sources are there, and then poorly cited sources are there. But in average, you have 30 citations per document per year, which means if you publish in a Q1 domain in this area, you get 30 citations per year in nutshell. So right now, let's move on to this. Now, this visualization was done from that .bib file. And I specifically picked this gray colored spots. I just selected this author, Majestic, to show you how this we call this three field visualization. And it gives you an idea about the left-hand side is about the keywords that the authors have used in this particular research domain. And the center, I specifically chose the authors. You can change that, of course. And then the right-hand side, rightmost side, shows you the sources, the journals that have published the research. So in this one, you can see as a whole, the GIS and spatial modeling and remote sensing, the size of this little height here shows you that which keyword has been used a lot. So you can see GIS has been used a lot, remote sensing, spatial modeling, those things have been used quite a lot. And then you have the authors who have published fairly high number of papers in this area. And with this, you can find who are the key players. So if you find an article from one of these authors, then you can actually base your assumptions, or you can think that this is the science behind it, and you can focus more on those kind of. I'm not telling you to just focus on one, but I'm saying you can pick who is doing what. And then you can see the sources right at the rightmost. This is very interesting and important because when we deal with undergraduate students or graduate students, most of them are their first encounter about research comes from maybe the 4th year or after graduation. They don't know much about journals or index journals or index conferences and these things. So identifying sources is very important because you can then think about the pedagogy, which means that the highly used keywords, the language they use, and understand how that particular area is behaving. You can refer to these specific sources and then maybe get more information about your research, because you will become, the mold is what that creates you as an expert in this area by looking at these sources. So I think this is a very interesting visualization about the literature. So this is about visualizing your reading, the way that you should read. And another visualization that I made from the literature itself shows you, now for example, there are papers that are seminal in one sense, and then there are papers that are connected. So this particular example, although I'm not really highlighting this one, but I just want to show you an example. You can see that one particular paper has a lot of connection to the left-hand side, which means, for example, if you want to get an idea of a particular application, say, for example, one thing may be about transportation in this case, maybe about public transportation in this case. So if you find so many articles related to that particular area connected to one paper, maybe reading that paper would give you a good idea about what to read next. Maybe you are doing a review and you need to see what papers are connected and where to look for them. And of course, maybe you have a friend in some other country who can download one paper for you. Then maybe it's one chance, then you can just send the most relevant paper and ask him to download. You can think of any other example, but this will give you a good idea about the connectivity and which paper is converging to what, right? So that's one thing. And the next one is this. Now, when we finally try to publish a paper, we are asked to find suitable keywords and try to find out where our particular research focus lies. So you can see that most of these the area of the visualization gives you the number of times a particular word has appeared in the literature. So geographic information systems, because of this query, those are the highly appearing words in this area. But let me take you to specific thing. Now say that your research is about air quality, or it's about United Kingdom, or about India, about water pollution, agriculture. You may you may be a researcher focusing on those areas. So it means that your research also has a part in this domain or in this area, so that you can focus more on the research that are relevant to your particular scope or particular research question. But if you try to read everything in 225 articles or in the original file 3000 something, then you will not be able to identify this whether you belong to a part of this community. So you have to find out that. I'm not suggesting that you should follow this, but I'm saying that you can do it. So by doing this, you identify whether you belong to this peer community, and the language that you use, the keywords that you use, the visualization that you use will be easily identified by the peers in those areas. And I have trend topics also, just to show you how visualizations can be used to see the emerging topics, the trend topics. For example, if you are trying to do your thesis, you're trying to find out the novelty in your thesis, you can find some of the words that have been used in the past may not be the ones that have been used in the present. So I can think of which topics would be trending, and so forth. I just leave it there without further. And I've included some other ways of visualizing the literature so that you can identify not only the sources, but also the authors. Because sometimes you can reach these authors because we are connected globally using ResearchGate or any other ways. You can actually identify who is the one dominating this area. Maybe you can talk to one of their postdoctoral students, or directly reaching the professor himself or herself. So this is also giving you a good idea, because that will give you an impression about who is a leader in research. And of course, if you are in a group that that's looking at citations or trying to position yourself in the global research community, it's very important to have the number of citations and your impact. So being the topic about impact, I would say this is also a nice visualization of this research area being cited by maybe interdisciplinary and interdisciplinary domains. So again, some relevant words. So I just skip this part, and then I will hand over this to Tiloka to talk a bit about some interesting facts.
Thank you, Sandun. I think probably what you just discussed was the most useful for the young people who are starting or in the middle of their own work in terms of positioning themselves, being more efficient in what you read and how you read and so on. Let's very quickly now just touch on some of the principles that you should think about when you're developing a good visual, the final piece of the puzzle, your own results. So let's go back to Menti for a few minutes. And I would like you to answer a couple of questions on the Menti platform again. And let's see whether we can use that to get some of the ideas across. So if you can go back to menti.com, same code. We'll wait for some people to join. If anyone else is planning to join, you can do so while the question is open. Okay, so let's go on to the first question. It's in the form of a quiz to make things a little bit interesting. Okay, so look at the picture which is given on your phone and see if you can answer the question. Okay, so what you were asked to do was to identify in the pie chart that you could see what was the third largest segment, not the biggest, not the smallest, but the third largest. And we had only 11 participants, but only 4 of you got it right. 7 of you did not. Okay, so let's move to the next one. Now we need to identify the third tallest bar in the bar chart. Okay, so now we have 11 of you who have got it right, a much higher rate than what we had earlier. It's the same information presented in 2 different ways. So the first one was a pie chart. Now we have the same information in a bar chart, and you can already see a lot of people are getting the answer right compared to when you were looking at the pie chart. One more question. Now only one person got it right. When you were asked to identify the comparison of the volume of the cubes, it was from Sajid. The only one who was able to internalize and compute the volume of the picture that you were looking at. So that brings me to a specific point. I wasn't just testing your eyesight. This is related to the principles of visualization and how our brains process information. So there are certain types of ways in which you can convey a message which is more effective than others. So according to this particular graph, it's based on scientific research. Looking at the length of a bar or a position on a scale is considered to be the most effective in terms of if you want to make comparisons between different values. Whereas as you move down this line, you're getting into kind of things which are harder and harder for the brain to process. So you see area is a little bit, not a little, it's harder. So the pie chart slices were harder for us to understand than the heights of the bar chart. The volume is even harder. So if you were to look at the volume of a cube, it's very difficult for us to kind of wrap our heads around how do you compare that. And then going down the scale, you have color saturation, which tends to be one of the hardest in terms of making comparisons between kind of precise values. So let's just try one more question. Okay. And that proves the last point that I made about color saturation as well. So the picture that you were looking at had these 2 cells marked A and B. And one appeared to look darker than the other, but that was purely because of the colors that were surrounding it. So when you're using colors, something that you need to be very careful about is what you are, like what you have around it, right? So the way that the brain computes and perceives color is not as straightforward as you would think when you're making the graph. There are lots of factors, preconceived notions about what high and low would mean, how a color looks next to other colors. things like how intense or bright a color is, all of these things have different meanings to different people depending on who is looking at it. So all these points are to kind of highlight that when you're creating your visual, you may think it looks nice and you may think that it gets the point across, but you need to consider these other kind of facts about what makes a visual good. So very often it's good to get someone else to look at it before you kind of go for the final version. That's what reviewers are for, of course. But if you have colleagues or friends who can also just have a look at your graph and see whether what you are trying to say is what they get from looking at the image, that would often help a great deal as well. So just going back to the last part of the presentation, maybe we won't take too much of time on this. The guidelines are here. We can share the slides with you as well. A few tips or guidelines to follow when you are preparing your own visuals. So back to Sandun.
Thanks, Tiloka, for pitching that up. Actually, we think that it's the time that we move on with what we have discussed. So here you have a similar kind of a narrative where you have a value, saturation, volume, area, and angle. How different types of visualization will be perceived by your brain, and of course, you can imagine what would be the story behind this. So you can look at the value 15 gives you a saturation, volume, and area, and angle like this. So the 30 gives you this. So if you just have this information, if you are asked to elaborate on this or interpolate, extrapolate on this, it's very difficult. And you can identify which types of data visualization would be more suitable. For example, the length in this case is suitable and easy to see, and the value, and so on and so forth. So one takeaway that I want to give you here is that when most of you are dealing with finite element analysis or maps, heat maps or whatever, you think that just giving the color would be more suitable and easy to follow. But you totally forget about giving that extra bit of information about the number and then giving the gradation and all. So if you don't give this, it's very difficult to, you can see, even though you think that the saturation, color, and the way that you present is easy to see, but it's not. So at the end, the problem will be the peers cannot read it, understand it, and then you have wasted time. There's a saying in visualization that you should not visualize something that is totally off, and better not to visualize at all. So that's the takeaway that we want to tell here. So I have I hope I'm audible. So yeah, based on the variability of these things, you can see A is a univariate or just single variable, and B is more of giving you an idea about two types of things. One is a class, classification, and the size. So the easiest thing to look at is if you can include colors to indicate maybe different classes, gender, or whatever that you want to show as a class value, categorical variable, and then you can use the size as an indicator of your numerical value. So that's the level, the degree, I mean the next level of visualization. The third level, the C and D plots, they indicate how you can convert your numerical summaries and compare those with the other. So for example, the bar chart indicated here has a distribution, the mean plotted at the top of its height, and then you have a line plot which gives you the variation. So another degree of information, how it varies with time maybe, with different concentrations or whatnot. You can think of different ways of visualizing. I'm just giving you the example. So this is the basic types of visualization that you find from one from the univariate type to comparing variables. Now I move to the next part. This is bivariate distributions, where you have multiple, or in particular, two types of variables distributed and moving in space, maybe time. So you can use scatter plots and 2D histograms to give you an idea about how two different variables would be distributed. And then you have heat maps that will give you an indication, maybe spatial or temporal variation of a variable, some degree of variation. And the map, of course, gives you a spatial and temporal variation. And the ith chart, you can see varying in the complexity. You can think about correlation and, of course, outliers and the degree of the noise in your data, because the line indicates maybe a predictor variable. And then you have the shaded area indicating how the values have distributed alongside those lines. So think of an example visualization that you might think would be suitable for your data using this. Now I go to the most complex types of data visualization, which is this. Now you have multivariate, where pairwise relationships, quantitative and qualitative data visualization all combined together. So the J-type scatter plot matrix gives you an idea about univariate. If you look at along the axis, you can see univariate nature of the data, X to X correlation. That means how the data is moving and how it is distributed. Then when you look at a notch up, that gives you, for example, here XY correlation, how they are plotted with respect to X and Y here, and X and Z here in this case. And this violin type of plots give you a bit more information rather than numerical summaries. It gives you the distribution of the two types of data along two axes. So the Y and X here, sorry, Z and X here, Z distribution here, and then X distribution here, with a box plot indicating how they belong to this entire distribution. And we move towards the K and L plots. These are somewhat bit complex, and it will be, if you are giving these type of visualizations in your papers, my suggestion as a reviewer as well would be to give a good narrative and give a good guideline for your reader to take him or her, walk him through this visualization in a narrative form, so that they know what they are looking at. It's difficult because to grasp at the first go what this means. And if you are going to use this kind of a map and this kind of a complex visualization, it's very important that you come up with a good narrative and pointing out and more descriptive as possible for your reader. It's actually for you. At the end, it will be an impactful visualization. Now, let me I think it's time for us to have a discussion about examples, because we thought it's good to show how we walk the talk sometimes, but again, it's something that I think you also would relate to. Now, this is one of the papers that I published, but for the time being, just forget about that. But look at the distribution of the data. This is one of our research students. He came up with this thing, and this is the summary of all the data related to this research. So you can see it's actually the first impression. So even not the first impression, this is after 3 weeks or 4 weeks of arranging things, and this is what we see. Now, simply what this means is there are different types of paver materials, paints on top of different pavers, and how the temperature profile varies. So you can see they are clustered together, and it's very difficult to compare them. Right? This is the data set that we got from the research. So how do we convert this from this form to a published research? Let me show you. It was not easy. It took like 3 months to come up with this. So as you can see, the narrative is there is this temperature variation with the 6 a.m. to 8 p.m. in a tropical country, of course, it's Sri Lanka. And then you have the relative humidity and the temperature profiles, how they vary. And after that, the main idea that we want to convey is that depending on the color of the paver, the temperature profile will vary. So we had to come up with this narrative and then organization of the data based on the narrative that we want to tell. So we tried different graphs. Actually, I can't show you all the stuff that we tried, but we all agree on this particular figure 6, because this is the prime outcome of this research. So we agreed on this because it gives you a temperature feeling. The red color gives you the temperature feeling. So at the end, it is actually qualitative, but you give that idea so that that the blue color and the green color and the other colors will give you that feel of temperature with respect to time. This is actually a heat map, but organized in a way that we want to show our narrative. There is no, we don't change the data, but what we do is we arrange the visualization to show our narrative. I think it's clear. And then of course you can see some of the times when we talk about visualization, people ask, are there any standalone software that can do all? Of course you can't. So we have combined several software sources, different types of tools to make this one single figure. So some of them were developed in one software, the arrangement was done in one, visualization was done in one, but mainly 3 tools. If I have the time, I'll talk about them. So this is how the final outcome is. Again, another research, this was done related to sensors located in a particular area. So these are the only data points that we got. So this little Excel sheet and some pictures of the place. So we had to tell what we were trying to tell. So then I'll show you what the visualization looked like. So we had to make it, as Tiloka initially mentioned, to make it abstract how the sensors were located and what is this data about, and how to visualize the movements and how different zones have reacted to this, and then of course our predictions and all these things. So the figure 9 was an outcome of all those thought processes and visualizations. So my take-home message here is that sometimes visualization is not straightforward. Sometimes you have to spend 6 months, 7 months trying to figure out what is the ideal visualization for a research. So if you are a novice researcher, young researcher trying to start your career in research, best thing is to learn how to visualize at the very early age and try to use that in your research. Because with time, you will be a much better researcher who can show this to a broader audience at the same time to your own peers, which will give you a higher impact and at the same time good visibility among them, because these are very straightforward when it comes to the final outcome. So I think it's time to wrap up, and I leave you there, and so I move to Tiloka.
Dear participants, actually this is time, so you can ask any question. So then I have a question. So actually, then before I thought of applying this during the data analysis process, then we are calling to this session of your discussion. Then so we can apply this during the literature, and according to your view, we should learn this from our early stages. Okay, so actually, Dr. Tiloka, so then data visualization process. When do we plan this? Then after collecting data, or should we plan this before collecting data? I mean, before collecting data, we have to do so many things. So preparing questionnaires. So normally we start our research with building objectives and their research questions. So, but then, according to this discussion, so before those things, we have to start this process. Is it, or then how can you advise our students in this regard?
Well, I guess, I mean, you can't plan your visualizations. It depends on the data that you have, right? I guess what you can do at the outset is visualizing your research in terms of where your work falls in the broader literature. So not your results, but where you are positioned in the wider research. I think there are lots of now publications that are purely focused on like this bibliometric analysis as well. But to be specifically answering your question, how do you plan your own visuals? I think it has to come after you get your data, right? Like you collect your data. You probably, I mean, how I would do it is I start with some basic visualizations just to get an idea of how my data looks. Then I do whatever statistical analysis that I have in mind to see what are the answers to my research question. And then the final part is again coming back to how can I present those statistical analysis results nicely, probably, hopefully with a graph. So I think you can do it at the start to get an idea of what your data looks like. But I think without having your messages clear, there's no point going for a visualization. You need to know exactly what you want to say before you go to the visualization. Otherwise, you run the risk of having like a series of graphs which are like kind of disconnected or don't really tell the story. So once you know what you're trying to say after you have done your analysis, that's when you can really think of what's the nicest way to put this visually. That's what I think.
Yeah, thank you. So then, Dr. Sandun, then according to the views of Dr. Tiloka, so then first we have to learn these things. So then, are there any resources that recommend? Because actually, there are some commercial groups and companies that provide assessment in data analysis. But the researcher doesn't have an opportunity to learn anything herself or himself in here. Therefore, it is not too value-added service for the PhD student. Certainly, if we want to make a powerful impact in our research, should we seek to advise of data analysis, or can we do it ourselves, or else what are the resources available to help our students in this?
So I will answer to that question following what Tiloka said. So sometimes when you are reading literature, as I mentioned in the discussion, if you see that some of your peer researchers are following a certain way of visualizing things, for example, if you are in the area of chemical engineering or civil engineering, they have certain types of particular visuals that are domain specific. So they know like thermodynamic charts or other slope plots or these things. So you have to first of all be very good at producing those domain specific visualizations. That is one thing. Coming back to your question, I don't think that having any advice from a data analyst point of view would help a research, because it is a personal dialogue. I would say it is something that comes to you. Like some of the visualization that I have made came to me maybe while walking or while playing with something else. So, because that is a part of the philosophy that you develop. Because it's not like just visualizing or analyzing and then coming up with the summary of the data or the numerical summaries, etc. Learning software and learning new things would be a bit challenging at the beginning. But if you are a researcher and if you are, say, you have 2 years or 1.5 years to go, you can master at least 1 or 2 tools that are related to visualization and analysis. So there are so many available resources, online tools and open access tools. So my advice would be not to rely on someone else, but of course, dialogue and discussion will help you to understand what to do and to see, look into the data, yes, but do not rely on anyone else. Maybe showing what you want to show comes from you itself. So if you can come up with some visual and then ask, can you see this? This is what I want to tell. And then if that person says, no, if you look at this, it will be much clearer, then you can try and then see, because that is also a process of developing your philosophy. So I think I answered that question in a broader sense.
Thank you. Actually, you have mentioned so many, several sites, then the softwares there. Can you point out again what are the open sources?
Yes, so now, pardon me if I'm talking about commercialized software, but I think most of the institutions, even in Sri Lanka, have the access to PowerPoint. So PowerPoint is a very good tool to start with. Excel and PowerPoint. If you are a novice researcher trying to at least see a sense in your data, you can start with PowerPoint and Excel. That's one thing. Then you have tools like Inkspace. Inkspace is an open source software where you can organize your data, like in the chart that I previously showed you, like organizing this type of different charts in single space. You can use open source software like Inkspace. If you are not having Illustrator or these Adobe high-end tools and the know-how to do And then R Studio is a very powerful tool of analyzing data and visually showing data, as I even mentioned in the discussion. So without any price tag, you can learn it. So many reasons are there. So if I were to pick, I'll pick these three: R Studio, Excel and PowerPoint, of course, those things, and then Inkscape. So if you have these three, if you learn how to use these three tools, then most probably 70 to 80% of your requirements are already met. So if you need more, that means you are using advanced visuals. Of course, if you need more, that means you are in that area, you need more things. So then, of course, you can read more. There are so many tools available in Python, and maybe you can learn about other commercial software as well. So that's how I see it.
Thank you. So dear researchers, you can ask any problems you have. Any questions?
Something was the open source you mentioned for the third one?
Inkspace. I think I can share it. It's there. It's called Inkspace. Inkscape, sorry. Inkscape. I'm sorry, it's Inkscape. I have this habit of changing the letters. You can, I'll put it in the chat.
Someone has a question. Tushar?
There's a race.
You can ask question.
Thank you for the very informative session on data visualization, and thank you for organizing as well as delivering. Actually, I saw one of the best visualized image for publications. Actually, Dr. Sandun showed us how a novel researcher can pick the most relevant publications. I can apply for library resources because since I'm attached to libraries, so we are in an economic crisis. So these visualization tools, you can help us to identify what are the most used journals in the field in our fields. Okay, so we can pick and subscribe because we don't have funds to subscribe whole databases. So if you can pick the most relevant journals, most highly used journals, or the journals having most citations, I think library can negotiate with the administration. And I thank again for the nice as well as very informative session. Thank you very much.
Okay, thank you for the comment. Dear researchers, do you have any questions?
Can you comment on the AI tools that are coming?
Actually, the Rabbit AI, that is an AI tool. Connected Papers is also visual analytics combined with AI. So I would recommend even using, like, there's a search engine called Find, Find. I'll share that with you. But AI tools per se cannot be used in your desktop or computer, so it's not the best of the things that I would say, because sometimes can be difficult, and also it will direct you to some other things that you don't know. So this is an AI search engine. I'm sharing that as well. This may be beneficial to people who are working in computational stuff or programming things, because Think research engine gives you good idea about it's an AI tool that gives you a good overview of research.
So we are going to wind up the research lab. So thank you so much, both of you. So it was a very nice and informative session, the way you want to conduct the session. So thank you so much again, and we like to work with you again. And dear participants, dear researchers, thank you so much for your participation. So then I will meet next research launch. It's also depend on the data part. Then we'll meet again. Okay, bye.